Hello and welcome back to my lectures on statistics. Today we're going to talk about data summarization, and we're going to focus on measures and summarizing data to find the center. So we're going to be focusing on measures of center. So the three main measures of center we're going to talk about are the mean, the median, and the mode. Okay, so the first thing we want to talk about is the mean. The mean is sometimes referred to as the first raw moment of a distribution. Okay, what that looks like is I have some probability distribution P of X. I'm going to sum that entire probability distribution by multiplying it by its support, which is X. And I'm going to do that with respect to X. If I do this for the entire domain space, this is going to give me what's known as the first raw moment, or the mean of the distribution. And we're going to use a Greek M to denote mean. As you can see here, we don't want this, I think this underline is going to get confusing, but as you can see here, this is the entire domain space. So we're going to call this the population mean. All right. The next thing we're going to talk about is so this is for, we'll call this for a continuous distribution. For a discrete distribution, all we're going to do is we're going to change this S to a Greek capital S, and we're going to rewrite it with the exact same integrand. Okay, so now we have the first raw moment of a distribution is the mean of a distribution, is this form here for continuous, and this form on the right for discrete. But what if we're only talking about a sample? If we're only talking about a sample, then my domain space here becomes countable and finite. So we're going to denote X bar as the sample mean. So we'll call this right here the sample mean, and it is discrete. And we're going to say this is equal to, instead of probability of X, I need my sample to be a random sample. So I'm going to put that here as assuming a random sample. This is very important. We're going to underline this. This is very important. Without a random sample, I cannot say that the probability of each sample point inside of my domain space is equally likely. That's why I can set this as 1 over n times the sum of all of my sample points, right? So this is discrete, so I can put an I here and I can put an I here. Okay, an example of finding a sample mean. So let's do example of a sample mean. So let's suppose I have a set of data X, and we'll say that it is 2, and we'll say 4, we'll say 10, and then we'll say, see, I got 16, and I want to divide it by 0, 4. Okay, so I've got 4 sample points. So n is equal to 4. So X bar is then equal to 1 over 4 times 0 plus 2 plus 4 plus 10. That's equal to 16 over 4, which is equal to 4. And so that is my arithmetic center of my distribution. All right, the next thing we want to talk about is the median. To find the median, we're going to find the middle of the support of the distribution under the probability density. So what that means is if I had some distribution, let's draw this out. Let's say I had some distribution. Those are my axes, and my distribution fell something like this. Then my middle, my arithmetic mean would be measured using this, but my median would be measured by finding the maximum, not the maximum, the 50% mark, the 50% mark. So that means if I shade this region in here, that this is 50% of X. Under, and this axis is P of X, and this axis is X, under P of X. So the notation for the median is the median of X is equal to, or you solve, let's say you solve 0.5 is equal to, and then we're going to write our same integral, X times P of X dx, but we're going to do this from negative infinity all the way to our median symbol, which I'll call, in this case, X tilde. Okay? So you're solving, in this case, you're solving for this X tilde here to find the median. So how do you do that in a sample? So to find the median of a sample, we'll take our X set back. We have 0, 2, 4, and 10. We need to find the exact middle here. Okay, it's important. Notice how in my original example it was ordered improperly, but in this example I have it ordered properly. The reason why I have it ordered properly is that this side of the x-axis here. This is the negative infinity side. This is the infinity side. This is the real number line. This is 0. So this is an ordered set here. So my x sample needs to be an ordered set here. And I need to find the exact middle right here. Well, it can't be 2 and it can't be 4 because 2 is not the middle and 4 is not the middle. I got to go between 2 and 4. So I need to find the midpoint between these two numbers. And the easiest way to do that is to do 4 plus 2 over 2, which is equal to 6 over 2, which is equal to 3. So that means my median x tilde is equal to 3. Let's say I have an odd number here. Well, if I had an odd number here, we'll call this x2. This is my second set of data. We'll just say 0, 2, and 4. If this were my set, 2 would be my exact middle, and I could say my median is equal to 2 for x2. All right, last, we're going to talk about the mode. So the mode of a distribution. Remember, or sample. So we're talking about modes, medians, modes, and means of distributions. Mean of a distribution, median of a distribution. Now we're going to talk about the mode of a distribution. The mode of the distribution is the x value that has the highest probability density or mass. So what that means is I want to find the x that is equal to the arg max of probability of x equal to some xi. We're looking for this guy right here. Right? So we're looking for this xi. All right, so what we're going to do for that, another way to write that is, let's say I had this distribution back here. Well, this right here is the max p of x equal to xi. So what is this thing right here? Under this drawing, it's 0, right? But if I want to find the median, so let's actually mode of a sample, then all I have to do is enumerate. So let's say I have this set right here, 0, 2, and 4. So if x is equal to 0, 2, and 4, then the probability x is equal to 0 is equal to 1 over 3. Probability x is equal to, I'm defining this probability function right now, by the way. 2 is equal to 1 over 3. And the probability x is equal to 4 is equal to 1 over 3. So this means that there is no mode of the distribution. However, if I said x is equal to 0, 2, 2, 4, now my probability x is equal to 0 is equal to 1 over 4. Probability x is equal to 2 is equal to a half. And probability x is equal to 4 is equal to 1/4. Now my mode of the distribution is 2. So the mode, we'll call this x1 and x2. Mode of x1 does not exist, but mode of x2 is 2. So these are all 3 different ways of measuring the center of a distribution and the center of a sample. Later on in this course, we'll talk about trying to determine the probability that a sample mode is equal to, or a sample mean or a sample median is equal to a population mean, mode, or median.